Good afternoon, students. I am Munshi Rashidul Islam, Assistant Professor, Department of Mechanical Engineering, JIS College of Engineering. Now, today, our discussing point is force analysis in helical gear and ohm gear. Now, first of all, we have discussed in last five classes that the total system of spark gear drives that can be discussed one by one in each and every classes from the last five classes lecture. But now today is the last session of this module on gear drives, but we have just concentrate about the today's point, that is actually the force and how can the force can be distributed, and some examples can be drawn out in these slides. But one question is there, and the force gear system, that I know how the gear system can be performed in such a manner that when the two systems two set of gears are in connected positions in a sequential manner. But how the force can be distributed, how the force can be generated during the gearing system, it is not actually visualized in actual cases. So for that reason, we can just describe the force analysis system in gear drive and helical gear and ohm gear in this lecture. Now, if I see in the bevel gear teeth profile, that is actually the right hand side where the each cylindrical shape are also be considered here. And if I point out one point where the W load will act, and as we know that the helical gear is a gear which is actually straight and parallel, but some angle will be helical gear design is similar to that of the spark gear design, but one difference is there. In helical gear and spark gear, the teeth profile are also mainly parallel and straight, but in gear drives, helical gear drives, in the teeth profile similar to that of the spark gear, except some angle also be there. That angle is called as a helix angle. And if I apply a load, suppose if you see the figure, that figure W load is applied in tangentially. So if suppose alpha angle also be there, and that alpha angle is called as a helix angle. So W is actually the total applying load with some certain angle, and the tangential load, that will be a WT, and the load which is actually acting in radial, that is actually WR, and with all some assumptions. So phi n is the normal helix angle, that is different for the different cases. Suppose some empirical formula also be there, where and W is equal to total average load applied on the point where the two elements are in contact to the other gear. So some empirical formula, that formula you have to be remember. Suppose the first one is total radial load, that will be WR is equal to W sin phi n, and WT is equal to W into cos phi n into cos psi, and WA is equal to W cos phi n into sin psi. That means all the equations getting from either in radial load, tangential load or average load, all the loads can be calculated in terms of the total load applied on the point where with some certain angle. Now WR is equal to WT into tan phi t, tangential angle, tangential helix angle, and WA is equal to WT into tan psi, and W is equal to WT by cos phi n and cos psi. That is actually the equation how to get the different types of empirical formula equations, and if I put all the value, we can get the result individually for the force system. And now this is actually one example problem of helical gear where the total loading system and total force can be distributed in such a cases of the helical gearing system. Suppose a 1 HP electric motor run at 1800 rpm in a clockwise direction as viewed from the positive x-axis and keyed to the motor shaft, and which is actually 18 tooth helical pinion having a normal pressure angle, and that is actually 20 degree, and the helix angle, normal pressure angle, helix angle is 30 degree, and the normal diametral pitch is 12 per inch. So the hand of the helix angle is shown in the figure. Make a 3-dimensional sketch and motor of the shaft and pinion. So the key forces acting on the pinion and the bearing reaction A and B, and the thrust should be taken out as A. So the figure is there where A is the fixed point and B also connected to the shaft where the gear are located, and in the large size gear total number of teeth is equal to 36, and small size gear, that means the pinion teeth number is 18, and the gap between the B point and the shaft, B point and the gear distance, that is equal to 3 inch, and then phi t, as per the equation, phi t is equal to tan phi n by cos psi. That if I putting all the value of tan phi n and psi, then we can get phi t is equal to 22.8 degree, and we know that the pt is equal to pn cos psi, that means the 12 cos 30, that means 10.39 teeth per inch. Now therefore the pitch diameter of the pinion dp is equal to 8 by 10.39, that means 1.732 inch, and the pitch line velocity v is equal to pi dn by 12, that means d is equal to 1.372, and n means 1800 by 12, that means 816 foot per minute. Now the transmitted load sigma wt is equal to 33,000 h by v. So h is equal to 1 means 1 horsepower, and 33,000 into 1 by the pitch line velocity 816, that means 40.4 foot-pound. Now WR, WA and W, all the value can be calculated. WR is equal to WT into tan phi t, WA is equal to WT into tan psi, and W is equal to WT by cos phi n into cos psi. And if I put the all values, we can get the W values, and the force directly acting on the point C, which is actually located at the average value of W is in the direction which is actually towards the C, and WT is actually the tangential load, and obviously WR is equal to radial load, and split the all values in respect to the value coming with some point, and that point will be relative to the total load applied, that will be 49.6 foot-pound. that is another problem where this problem continuing, and the total value of the total number of teeth or total number of teeth, total number of torque, and also the total direction of the moment that can be calculated in such a way that you have seen in the screen. Now the total torque which is actually applied, that means T is equal to Wt into dp by 2. So Wt is equal to 40.4 and dp is equal to 1.372 by 2, that means 35 foot-pound inch. And that is actually the reaction how the systems can be followed in the cases. And the total moment taking about A, so that will be Rb into Fb plus T plus Rc into W is equal to 0. And if I put all the value, so Fa is equal to, we can get Fa is equal to 23.3 I minus 3.1 J plus 12.1 K foot-pound. And this is actually the case of Ohm gear analysis. In Ohm gear analysis, similar to that of the helical gear, Ohm gear analysis, some empirical formula also be there, and that is actually Wx, the load with x-axis, that is equal to W into cos phi n into sin lambda. Wy is equal to W into sin phi n, and Wz is equal to W into cos phi n into cos lambda. And if I see the figure where the total load is also be there, pitch helix angle also be there, and pitch cylinder that can be considered, where the total pitch point can be created and the mating point also be marked, and total load distribution can be distributed with some axis, and that axis may be assumed in terms of the phi n or lambda. And now W into Wt, total load with the tangential segment, then tangential area, that is equal to W minus Wga is equal to Wx. Wr is equal to Wgr is equal to Wy, and Wga is equal to minus Wgt is equal to Wz. That means xyz axis, according to xyz axis we can get the different value with respect to the minus symbol, and the gear and pinion also be considered here with the pitch helix angle. Now review from the force analysis on the Ohm gearing. Now the relative motion in the Ohm gear is sliding acting. Friction is much more significant than the other system of gear, and including friction components that can be expanded to the equation, that is actually Wx is equal to W into cos phi n into sin lambda plus x f cos lambda, and Wy is equal to W sin phi n, and Wz is equal to W into cos phi n into cos lambda minus f sin lambda. Now combining with equations and 14.42 and 14.3, so we can get Wx is equal to f into W, that means f Wgt by f sin lambda minus cos phi n into cos lambda. That means Wt is equal to Wgt cos phi n sin lambda plus f cos lambda by f sin lambda minus cos phi n into cos lambda. Now the efficiency of the Ohm gearing. Efficiency is defined as the Wt without friction and by the Wt with friction. That means when the f is equal to 0 in the numerator, that means eta is equal to, eta means Ohm gear efficiency, eta is equal to cos phi n minus f tan lambda whole by cos phi n plus f cot lambda. And now that is actually the equations which vary from the helix angle to the efficiency. If helix angle is much more helix angle increase, that means efficiency also be increased. But some cases some exceptional case also be there. With typical value of f is equal to 0.05 and phi n is equal to 20 degree, the efficiency as a function of helix angle is given in the table. Now Ohm gear efficiency, the coefficient of friction is dependent on the relative or sliding velocity Vs, and Vg is actually the pitch line velocity of gear, and Vw, which is actually the pitch line velocity of Ohm gear. So Vw is equal to Vg plus Vs. So Vs is equal to Vw by cos lambda. And coefficient of friction for Ohm gearing. Graph shows representative value. Graph A, which is actually mode efficient friction is expected, and such as when the gear are also the cast iron. And graph B, which is actually the high quality material can be used. And now this is actually the Ohm gear problem, and this problem you have to be followed in your home practice or home homework. And it, I think, all the process, all the parameter, all the design related formula that can I already explain. If you follow the properly, you can you can easily solve this problem. And this is actually a simple problem, and maximum the problem can be followed by the empirical formula that I mentioned in earlier slides. So these are the process to solve the problem, and so this is the end of the problem. So last 5 slides mainly the solution of the problem, how the Ohm gear problem can be solved. So this is actually the total scenario starting from the 21st lecture to 26th lecture. All 6 lecture mainly occupied for the gear drives process and gear drives mechanism. So thank you for watching.